So the question we're doing here is we need to prove by mathematical induction that n to the power 4 plus 2n cubed plus n squared is divisible by 4. So what we do here is we go to the first step where we show that this statement is true when n is equals to 1 here. So meaning that where there's n there, we're going to replace with 1. Then the number that we get, we divide by 4. So if there's no remainder that we're going to have there, though, it simply means that it's true for n equals to 1. So if there's a remainder there, then the statement is not true for n equals to 1, so our proof ends there. So now, step number 1, we need to show that this is true for n equal to 1 here. So meaning that here we get the expression that we have n to the power 4 plus 2n to the power 3 plus n to the power 2 here. Then we substitute where there's n here, we substitute 1. So we have 1 to the power 4 plus 2 multiplied by 1 to the power 3 plus 1 to the power 2 here. So this will just give us 1 plus 2 plus 1, which will give us 4. So this 4 that we have here, if we divide it by the 4 that we have that were being asked in the question there, you'll find that we're just simply going to get a 1 without a remainder. So we make a conclusion that it's true for n equal to 1 there. Okay, so we go to step number 2, which is the inductive hypothesis. So inductive hypothesis, let me just erase this. Okay, so inductive hypothesis so here we make an assumption, or rather we assume that this is true for n equal to k here. So meaning that in this expression that we have there in the question, everywhere where there's n, we're going to substitute with k, then we equate it to 4m there. So here, say we have k to the power 4, k to the power 4 plus 2k to the power 3 plus k squared here is equal to 4m like this here. So we can just make k to the power 4 the subject here. We can just put everything this side. So we have k to the power 4 will be equal to 4m minus 2k to the power 3 minus k squared like this here. So then after this we go to the third step, which is we need to show that the inductive hypothesis that we have here is equally true for n equals to k plus 1. So here we say we need to show that it's also true for n equals to k plus 1. So we get the expression here, then everywhere there's n there, we substitute k plus 1, then we don't equate it to anything, we just start simplifying the expression there. So we're saying here we're going to have k plus 1 the power 4 plus 2 multiplied by k plus 1 to the power 3 plus n squared like this here. So now if we expand k plus 1 to the power 4, we're going to have k to the power 4 plus 4k to the power 3 plus 6k squared plus 4k plus 1 like this here. Then the expansion of this term here, we're going to have 2. So plus 2, open brackets, we have k to the power 3 plus 3k squared plus 3k plus 1 plus, so when we expand k plus 1 here, so let me just erase that and write k plus 1 there. So we have our k plus 1 squared here. Okay, sorry about that. Okay, so now when we expand this term here, we're simply going to have k squared plus 2k plus 1. So we have k squared plus 2k plus 1. So here we have plus 1 like this here. So now we have k to the power 4 plus 4k to the power 3 plus 6k squared plus 4k plus 1 plus 2k to the power 3 plus 6k squared plus 6k plus 2, and we have plus k squared plus 2k plus 1 like this here. So if we add all the terms that we have here, we add the like terms together, so we have 6k to the power 2, 6k to the power 2, and k to the power 2 this side here. Then as well we have 2k to the power 3 and 2k to the power 3 there. So then again, so we're going to add all the like terms that we have there. So we have k to the power 4 plus 4k to the power 3 plus 2k to the power 3. We get 6k to the power 3 plus 6 plus 6 plus 1 this side, we're going to get 13. So here we say plus 13 there. Then plus, so we have 4k here and we have 6k there, so that gives us 10k plus 2k, that goes to 12k there. So we have plus 12k plus, we have a 1 plus 1 plus 1 this side, then a plus 2 here, so we get a plus 4 there. So now on the second step here, the inductive hypothesis, we say that k to the power 4 is equals to 4m minus 2k to the power 3 plus k squared here. So if we make that substitution there, we have 4m minus 2k to the power 3 minus k squared plus 6k to the power 3 plus 13k squared plus 12k plus 4 like this here. So then here, let me just scroll down a bit. So here, you notice to say that here, we're simply going to remain with 4m plus 4k to the power 3 plus 12k squared plus 12k plus 4 like this here. So here we can just factor out 4 there. So we have 4m plus k to the power 3 plus 3k squared plus 3k here plus 4 like this here.